Okay guys, so welcome back to the channel. So in this video we want to be focusing on differentiation rules, right? The rules of differentiation, and this is just to introduce a few rules that will allow us to differentiate a lot of functions. And so we're going to start with rule number one, straight to the point. So rule number one is what you call the constant function, or the different derivative of a constant function. So the derivatives of a constant function, this is where if f has a constant value, for example, if you have f of x which is equals to c, right, then the derivative df over dx equals to, which obviously is going to be d over dx of that constant, it's going to give us 0. So the differentiation of any constant function is always 0. That is the basic rule of deriving constant functions. So let's look at an example. So let's say we have f of x equals to 8, right? That means d over dx of 8 is going to be 0. As simple as that. So similarly, if we have, for example, another function where f of x equals to, this is another example, example 2. So this one we're going to call it example 1. If we have, for example, f of x equals to minus pi over 2, then f prime is another way of writing df over dx, right? Is another way of writing df over dx. This means the derivative. So this one means the derivative of f, right? So the derivative of f in this case will be 0. Why? Because this here is a constant. This is a constant. So rule number 2. Rule number 2 is what we call the power rule. So you go to rule number 2. Rule number 2 is the power rule for positive integers. So this is the power rule for positive integers. This is very important. Positive integers, right? So if n is positive, this, say for example, you have your function which is f of x equals to x to the exponent n, right? Let me write this nicely. X to the exponent n, and we assume that n is a positive integer, right? N is a positive integer. Therefore f of x, which is the derivative of x, it's going to be, you're going to take the n and you're going to multiply it with the coefficient of x. In this case, the coefficient of x is 1 here, right? The coefficient of x is 1. So you're going to multiply it with that 1 here, and then obviously you're going to rewrite the x, and then you're going to minus that n by 1. So for example, let's say we have f of x equals to x to the exponent 5. This means that the derivative of f of x is going to be 5 x to the exponent 4, right? Or you can say x to the exponent 5 minus 1, which is 5 x to the exponent 4. So this will be the answer. This is known as the power rule. Let's do another example. This is our example 1. let's do another example 2. Example 2, we have f of x, which is 4x to the 6, right? So the derivative of f of x, obviously you're going to have 4 multiplied by 6, and then x, 6 minus 1. So 4 times 6, this gives us 24, x to the exponent 5. So this is the derivative of f of x. This is the derivative of f of x. So it's very important to understand this rule because you're going to be using it a lot in the future. Then we move to rule number 3. Rule number 3. This rule is called the constant multiple. Constant multiple, right? Or constant multiple rule. So if, for example, you have a function, let's say you want to differentiate, right? A function f of x. A function which is c multiplied by a constant multiplied by a function, right? This is equals to the constant multiplied by the derivative of that function, right? Constant multiplied by the derivative of that function. For example, let's say you have the function, let's say example 1, you have the function 3 multiplied by x squared. Now in this case, we're going to treat x squared, this x squared over here, we're going to treat it as our f of x. And then this 3, we're going to treat it as our constant. So this here, it's going to be like our c, and then this one is going to be like our f of x, right? So the derivative of this function, it's going to be 3, which is the constant, multiplied by the derivative of f of x, right? Which is 2x. We're using the power rule. Then obviously the final answer is going to be 6x, which is the final answer. So this is the constant multiple rule of derivation. Then we move to rule number 4. Rule number 4 is called the sum and difference rule. So we want the derivative of the sum or difference rule, right? This is the plus or minus rule, right? So what does this rule states? The rule states that if you have the derivative of two functions, f of x plus or minus g of x, right? This is the same as the derivative of f of x plus or minus the derivative of g of x. For example, suppose you have example 1. Suppose you have the derivative of f of x, which is sine x, right, plus 3x squared, right? This is equals to the derivative of sine x plus the derivative of 3x squared. And obviously you're gonna solve this derivative, and then you're gonna add it with this derivative over here. This is the sum or difference rule, and you can add a minus you can add a minus here. So it's still applicable. Whether it's a plus or minus, it doesn't matter. The rule, same rule applies. So, for example, another example, I'm going to give example 2. Example 2. Suppose you have y, which is equals to x to the exponent 4 plus 12x, right? We're going to treat this as our f of x, and then this one will be like our g of x. So, which means the derivative dy over dx of this function is going to be d over dx of x squared, x to the 4 plus d over dx of 12x, and then obviously dy over dx, it's gonna be this one is gonna be 4x cubed plus this one is gonna be 12. Then this is your final answer. This here is your final answer. So this rule is the sum or difference rule. Now we want to move to rule number 5, which is known as the product rule. Rule number 5 is known as the product rule. So let's do rule number 5. Rule number 5 is the product rule. This is when you are differentiating the product of two functions. When you have two functions and you want to differentiate these two functions that multiply each other. For example, if you have, for example, the function f of x equals to h of x multiplied by g of x, right? So for you to derive this function, if you want the derivative of this function, you are going to apply this important rule. You're going to first differentiate this function. Let me write it properly. You're going to find the derivative of h, then you multiply with g of x. Then you're going to add the derivative of g of x, then you multiply with h of x. This is how the rule applies, right? So let us do an example of this function. Suppose you have the function y. This is an example 1. You have the function y, which is 3x squared plus 4 multiplied by x cubed plus 3, right? So these are two functions. Here's one function. This one we can treat it as our h of x, and this one we can treat it as our g of x. So this one can be like our h of x, and then this one can be like our g of x. So what does the rule state? The rule states that dy over dx is what? Is the derivative of this one. The first one, which is h of x. You're going to derive this one, then you're going to multiply it with this one, right? That's the first step that you have to do. So you're going to take h of x, you derive it. When you derive h of x, you're going to get 6x, right? Using the power rule. Multiply by this other function, which is x cubed plus 3, right? Plus, now you switch. You now derive the second function, which is 3x cubed, right? Then multiply it with the first function, which is 3x squared plus 4. Then once you're here, you can easily simplify. So you can say dy over dx. Then you can easily simplify. You can say 6 multiplied by that. You get 6x to the 4 plus 6 times 3, you get 18x plus 3 times 3x squared plus times 3x squared. That gives us 9x to the 4 plus 3x squared times 4. That gives us 12x squared. Then dy over dx, you look for like terms. Obviously, these two are like terms. So you're gonna obviously say 6 plus 9, that gives us 15x to the 4, right? Plus 18x plus 12x squared, and this will be your final answer, right? So it's very, very important. So now we move to another rule called the quotient rule. So rule number 6 is known as the quotient rule of derivatives. Quotient rule. This rule is when you are dividing two functions. So if you have, for example, the derivative, right, of two functions, one function is u, the other function is v, right? You have two functions, u and v. How do you get this? So what you do is that you're gonna derive the top function, which is u. So you're gonna find the derivative of u, then you're gonna multiply it by v, right? Then you're gonna minus the derivative of v. So you're gonna look for the derivative of v, then you multiply by u. Then you're gonna divide by v squared. This one here that is on the denominator, you're gonna square it, right? And that's how you find the derivative of two functions that divide each other. Now if you can write it again, we can write it like this. If you have two functions, f of x over g of x, right, this is equal to the derivative of f multiplied by g minus the derivative of g of x multiplied by f of x all over the derivative of g of x all squared. Always the denominator gets squared, right? So we're gonna do a quick example. Suppose example 1. Suppose now you have y, which is equals to t squared minus 1 all over t squared plus 1, right? This is your function. Then you want the derivative of this function, right, which is to find dy over dt. We are differentiating with respect to t, right? Now what do? Remember, this one here is like your u, and then this one here is like your v, right? So what do? You differentiate u, which is t squared minus 1. You differentiate it, you're going to get 2t using the power rule, multiply by t squared plus 1, which is your v, right? Then you're going to minus, remember the rule, minus the differentiation of the bottom function, which is 2t also, right? Multiply by the top function, is t squared minus 1 all over t squared plus 1 all squared, right? Then you're going to get dy over dt equals to, then now you can simplify, then you're going to get 2t cubed plus 2t minus 2t cubed plus 2t, then this is all over t squared plus 1 all squared. Then to further simplify, we'll look for like terms. Our like terms is this one. These two cancel each other. I don't know if you can see it. These two, they cancel each other. And then we have these two adding each other. So we have 2t, 4t over t squared plus 1 all squared. And this is our final answer. So these are the rules of differentiation. In the future video or in the next video, I'm gonna add more rules, but for now we will suffice with these 6 rules. There's still more rules that we can do, such as the differentiating the power rule for a negative integer, right? As well as differentiating trigonometric function, differentiating exponential function, differentiating logarithmic functions. Those are things that I will discuss on the next video. Please don't forget to subscribe.